and welcome to the fourth video under Programming in C. Functions break large computing tasks into smaller ones and enable people to build on what others have done instead of starting over from scratch. Appropriate functions hide details of operation from parts of programs that don't need to know about them, thus clarifying the whole and easing the pain of making changes. C has been designed to make functions efficient and easy to use. C programs generally consist of many small functions rather than few big ones. A C program consists of set of external objects, basically which are either variables or functions. The adjective external is used in contrast with internal variables, that is, which means that variables that describes the argument and variables defined inside the function, they are called internal, and the opposite would be external variables. And these are thus potentially available to many functions. Functions themselves are always external because C does not allow functions to be defined inside other functions. By default, external variables and functions have property that all references to them by the same name, even from function compiled separately, are references to the same thing. Because external variables are globally accessible, they provide an alternative to function arguments and return values for communicating data between functions. Any function may access an external variable by referring to it by name if the name has been declared somehow. We had seen about headers in previous videos. Headers, for example, like if I recall, then there would be hashtag include.stdio.h or math.h, etc. Each header has a specific range. So basically, stdioh would be for standard input and output programs that we write, and programs like where complicated mathematical calculations would need math.h. So header file is where you declare what type of program you're going to write, and then inside that we write the main function, and inside the main function you write the block of your code. Static variables. The variables in buff, buffy, or in getch are private use of our functions and their respective source files. And they are not meant to be accessed by anything else. So basically, the static declaration is applied to an external variable or function which limits the scope of that object to the rest of the source file being compiled. Thus, the external static provides a way to hide names like buff or buffp in the get or unget combination, which must be external so that they can be shared. Now coming to register variables. A register variable is basically the declaration advises the compiler that the variable in question will be heavily used. So the idea is that register variables are to be placed in machine registers, which may result in smaller and faster programs. But compilers are free to ignore this advice. What would a register declaration look like? It would probably be like register int x or register char c, right? So register declaration can only be applied to automatic variables and to the formal parameters of the function. It can also be reflecting the realities of the underlying hardware. Only a few variables in each function may be kept in registers, and only certain types are allowed. Excess register declaration are harmless, but since the word registration is ignored for excess or disallowed declaration, we do not use it. And it is not possible to take the address of the register variable, regardless of whether the variable is actually placed in a register or not. That is it for this one. In the next one, we'll be talking more about different function uses. Thank you.